Lavender essential oil consists of many terpenes, two of which are linalool and linalyl acetate. These two terpenes have been shown to have remarkable antimicrobial and antibacterial qualities, both individually and synergistically. This study tested the antibacterial qualities of linalool and linalyl acetate standards on gram-negative Escherichia coli, Pseudomonas aeruginosa, and Salmonella enterica. We also tested the gram-positive bacteria Staphylococcus aureus. Essential oil was extracted from Lavandula angustifolia, also known as hidcote, as well as the French Lavandula intermedia, also known as phenomenal lavender species. The composition of these lavender species were characterized using headspace UPLC. It was hypothesized that these terpenes would show antimicrobial effects and interact synergistically with the antibiotics, which would reduce the need for high doses of antibiotics, preventing antibiotic resistance. The hidcote essential oil had 1030.63 and 1284.66 nanograms per microliter of linalool and linalyl acetate, respectively, where phenomenal essential oil had 13,045.12 and 20,525.08 nanograms per microliter of linalool and linalyl acetate, respectively. While other peaks were identified, these were the only two substances that could be quantified due to the standard curve. This suggests that all lavender species contain a substantial quantity of terpenes. Kirby-Bauer disc diffusion assay was performed to determine the antibacterial qualities of all samples. The samples included hidcote, phenomenal, linalool, linalyl acetate, as well as a combination of hidcote phenomenal and a combination of linalool and linalyl acetate standard alongside a control of gentamicin antibiotic. No zones of inhibition were determined for P. aeruginosa. E. coli had zones of inhibition for all treatment samples. S. aureus had a zone of inhibition for linalool and linalyl acetate combination, and S. enterica had inhibition for hidcote, phenomenal, linalool, as well as the linalool-linalyl acetate combination treatments. A checkerboard synergy test was used on all 4 bacteria using resizurin redox indication. Metabolic activity was negatively affected by the methanol salt at the highest dose of 16.7% to all the bacteria species. S. aureus and E. coli had low cell activity within most wells, causing synergy to be undetermined. Synergy was seen in S. enterica at 4 nanograms per microliter gentamicin, combination with 1,000 nanograms per microliter of terpenes. Synergy was also seen in P. aeruginosa at 1 nanogram per microliter gentamicin in combination with 500 nanograms per microliter of terpenes. This suggests that terpenes have potential to lower the antibiotic dosage for various bacterial species. Future treatments involving these volatile terpenes should be performed under the optimal environment so the temperature will not reach 20 degrees, which is the evaporation point of these two terpenes. Loss of terpenes ultimately affected the synergistic capabilities. In conclusion, linalool and linalyl acetate have exhibited antibacterial qualities for all 4 bacteria species. Future extraction using non-toxic solvent options should also be explored. Possible encapsulation of these terpenes could be a promising route for synergism to avoid antibiotic resistance among the population. I want to take this time to thank my teachers, Dr. Jessica Livingston, Dr. Michael Gibson, Marla McKenzie, and Crystal McFadgen for their continued guidance and support, not only on this research project, but throughout my time in the bioscience program.